Thank you so much, ma'am. It's my pleasure to introduce Dr. Nikhat Raza Khan, ma'am, Professor and Head of the Computer Science Department at Oriental College of Technology, Bhopal. Dr. Khan is a distinguished academician and researcher with expertise in networking, machine learning, cloud computing, and data analytics. She is a senior member of IEEE and ACM Ambassador and an active contributor to IEEE Women in Engineering. Her leadership in academics and research has earned her wide recognition, and her work continues to inspire students and researchers alike. We are delighted to have her with us as our technical session expert. Before we begin with the paper presentations, I would like to share a few important guidelines with all the presenters. Each presenter will have a total of 15 minutes. 10 minutes are allotted for the presentation. The remaining 5 minutes are reserved for the question and answer round. A gentle reminder will be given after 8 minutes to help presenters manage their time effectively. The Best Paper Award will be presented based on the evaluation by the session chairs. The evaluation will be based on the following criteria: rationale of the study, literature review, methodology, presentation clarity and organization, handling of the question and answer session. We wish all the presenters the very best. Our first presenter is Miss Richa Singh. Her paper is titled Machine Learning Assisted Genetic Algorithm for Adaptive Control Parameter Optimization in Wind Energy Systems. I request all the participants who are required to be in the conference hall kindly proceed there. I request all the participants who are required to be in conference hall kindly proceed there.
A very good afternoon, everyone. I'm Richa Singh. I'm a research scholar in Allen City University. I'm here to present my paper, and I'm big thanks to Bansal Group for providing me this opportunity to stand over here to present my paper and my presentation on machine learning assisted genetic algorithm for adaptive control parameters optimization in wind energy systems. So here I'll start with the outline of my PPT presentation, and that is abstract, introduction, literature review, research gap, objectives, methodology, results and discussion, conclusion and future work references. So now I'll start with the abstract of my PPT presentation of my paper. The abstract is telling us about the increasing penetration of wind energy in modern power systems requires advanced control strategies that can maintain high efficiency and operational stability even under the highly variable and uncertain wind conditions. So, there are traditional control methods such as proportional integral derivative, that's PID, and fixed parameter optimization methods often exhibit with limited adaptability and suboptimal performance when these all traditional methods exposed to intense wind fluctuations and system non-linearities. So these are the issues that I found. So to address these challenges, this paper proposes a machine learning assisted genetic algorithm, that is MLGA framework for adaptive optimization of control parameters in wind and power systems, with a particular emphasis on blade pitch control, which is the main crucial part of my paper. So here I propose the approach which integrates a data-driven learning model with a genetic optimization mechanism, which is a part of machine learning, which help us to enable intelligent and real-time adjustment of control parameters based on turbine operating conditions. Because in the wind turbine we are working on the blade pitch control. So genetic algorithm help us to optimize the better control results to, for the machine. So the learning components captures the historical and online behavior of the system to accelerate convergence and increase optimization accuracy, while adapting crossover and mutation strategies improve the robustness in dynamic environments, which is the crucial part of genetic algorithm. The effectiveness of the MLGA controller was evaluated through a MATLAB-based simulation, which I used over here in my paper, and under windy and turbulent conditions and compared with traditional PID and standard GA controllers. So after that, the simulation result shows, which I used through the MATLAB, the simulation result shows that the MLGA controller achieves an improvement of up to 12.77% of results, which is better as compared to the traditional methods. In average power output, better rotor speed control, and improved adaptability. These results confirm that the potential of ML and GA-based control as a promising solution for intelligent and efficient operation of the wind power system. So let's move forward towards the introductory part. So wind energy is one of the most popular and fast growing renewable energy sources because it is clean, widely available and environmental friendly. In wind turbine, the blade pitch control system is very important because it adjusts the blade angle to control rotor speed, increase power generation, and also reduce mechanical stress on the turbine components. Traditional control methods such as PID controllers are simply and widely used, but their performance may decrease under changing wind conditions, and system uncertainties. So here in genetic algorithms have been used to optimize the controller parameters, but they often reduce more computation time and may converge slowly. To overcome these limitations, this paper proposes a machine learning assisted genetic algorithm, that is MLGA framework. The proposed method combines an artificial neural network, which is a part of machine learning, with a genetic algorithm to improve controller parameter tuning. So by learning this system behavior, the optimization process, the ML and genetic algorithm approach improves power generation, rotor speed regulation, and adaptability under varying wind conditions. So here is the part of my literature review. So I find out, so many of the recently workers, the authors which are worked on this topic, so I found many key findings and the limitations of the research gap are also. So if I say in the third number of, which is recently published in 2023, AI-based design optimization review, which is the application areas wind turbine design, I found that reviewed supervised and unsupervised and reinforcement learning approaches. But the research gap which I found out, that is the highlighted data scarcity and interpretability challenges. And also in the 2026, there is again a paper, this SSA ELM, Sparrow search algorithm with extreme learning machine, which is application area, which is wind speed forecasting. And the key findings I found that is the improved prediction accuracy and computational efficiency. So here the limitation for that of that paper I found out, the research gap, which would say the limited to forecasting applications. And there's more on the papers, research papers which I found. So there is in the year of 2024 genetic gray wolf optimizer, which is used in the wind farm layout optimization, and the key findings are the improved local energy production and convergence, and the research gap I find out that is a focus on layout optimization only, not on the better performance or better efficiency when the fluctuation of the environment or the wind energy experiences by the wind blade. So here are the research gap. From the literature review, it is found out that most of the existing research focuses on wind speed prediction, system optimization, energy system sizing, or wind farm layout optimization separately. But many studies use machine learning or optimization techniques individually. But very few combine these approaches for adaptive wind turbine control. So, in wind turbines operates under highly variable and uncertain environments where wind, speed, turbulence, and speed system dynamics changes continuously. Therefore, there is a need for an intelligent control framework that can learn from system behavior and automatically adjust control parameters.
And just a gentle reminder that 8 minutes have already passed.
Oh,
So, 2 minutes are remaining and 5 for question and answer round.
Okay, there is the objective. The main objective of this paper is to develop and evaluate machine learning assisting genetic algorithm based on a adaptive pitch control system for wind energy conversion system operating under variable wind conditions. So here I use that methodology for the closed loop architecture of the proposed machine learning assisted genetic algorithm. Here the reference power which are given to the adaptive pitch controller, that is the beta angle, which works as per the reference power, or it helps the from the MLGA optimization layer with which helps in prediction and optimization of that pitch control. And if any kind of disturbance arrives, it can be measured by it, and the wind turbine gives the output which is form of the loop. So their difference always been zero. That can never be in any kind of value, because if we provided any reference power in watt and we get the output in the form of the same value, then our model is predicting or optimization has been successfully done. These are the algorithm which I use for that methodology. And these are my result and discussion point in which I work on with respect to the time seconds. These are, I compared all the work through the traditional PID and the GA controller, which is the standard methods, and I compared these all with my work, that is ML and GA comparison. And here the performance comparison of pitch control strategy. This is the performance matrix with the PID, which is the traditional controller method, and GA, which is the genetic algorithm, which is the standard one. And my work is on the ML and GA controller, which I get the better result. Here you can see by measuring these parameters, I get the much better results. Power stability is highest mean output, and control adaptability is high, and sustainability for variable wind is excellent. So here's the measurable values, and I get the power improvement over PID percentages better than the traditional and standard one, which is 12.77%. The conclusion in the future work, we can say, this paper proposes a machine learning assisted generative algorithm framework which focus on the blade pitch control under variable wind conditions. If we use the machine learning and the genetic algorithm, it will help to control or predict or optimize the solution better way in any condition.
Is over. But you may ask questions.
So, Richard, is this your first paper? First paper.
Second.
Second. Okay. So you have used GA.
Yes,
Can you please tell me about why you are using GA?
Ma'am, there is many optimization techniques, but GA gives me more better result if I combine it with ML, because GA is giving me a hyperparameter optimization technique, which is one of the application of genetic algorithm. That's why I'm using here in GA with my that wind energy model.
So how much percentage you have given the actual results using GA?
Only GA, ma'am?
Yeah.
If I use an only GA controller, I will get 8.77%, and if I use ML with GA controller, I will get 12.77%.
So you are using ML plus GA?
Yes, ma'am.
Okay. Which algorithm you use GA?
Sir, ma'am, I used ML algorithm of artificial neural network with genetic algorithm.
So can you please tell me the algorithm which is used?
Ma'am, I only use, this is the part of my algorithm, which I used machine learning assisted genetic algorithm for adaptive control parameter optimization. This is the part in which I merged the machine learning assisted with genetic. Genetic algorithm I have used and combined and enabled with machine learning techniques. Here is the steps with it. Can I explain the system, ma'am, as well? So I need to check whether what is the wind speed, what is the roller speed of the blade pitch of the wind turbine, and power output, that is P. And next requirement is population size N, and how much kind of variable I will require, or the maximum generation output, which is the G, capital G. And I ensure that optimized control parameter set with the theta star. So I initialize that kind of theta with from these are the variable number of input. Any kind of non-linearities will come when wind falling, any kind of environmental issues, because in my paper I didn't work on any kind of sensor techniques like any kind of obstacle come. I only work on the speed of wind or speed of the environment. Any kind of a storm can be happen naturally, which is naturally come. So I
How you
through
can calculate this?
yes ma'am.
How you can calculate this? The speed of the wind speed.
Ma'am, through MATLAB. I use MATLAB simulations. These are the results. These are the results, ma'am.
It is not declared in the serial code.
It's not showing.
It's not showing there.
You are not taking.
No. जाइए ना serial code पे जाइए. हाँ.
So this is only the algorithm part. I didn't
इसमें it must be
mention
included in
the
that.
yeah. But in my paper there is an all fill.
समझिए ultimately you have to ये तो आपको यहाँ बताना पड़ेगा ना serial code में.
I agree with you, sir. But here in my PPT, I only will present this algorithm part, and in the result discussion on mathematical evaluations, which we are talking about the mathematical expressions, I mentioned this on my paper. I didn't mention this on my PPT.
We are calculating the wind speed power, so the calculation is not showing here.
Not showing there.
Yes, ma'am. This is not on my PPT, but it is on my paper, and I worked that
So
mathematical.
even though it's not showing you pseudo words also, it's like it's not present. But how you can you're going for calculation part?
Ma'am, actually in algorithm I
How
only
the G is help? It's like ML and G is help. I'm not going to understand for this point. How it's help?
ma'am, machine learning, in part of machine learning I applied ANN techniques in which I work for the prediction of the results, and in
Which
the
prediction algorithm we have worked here?
ma'am, ANN.
Prediction algorithm.
No, ma'am. Here I only used the ANN combined with the genetic algorithm. I produces the result of that algorithm, and also I have some mathematical expressions which I have mentioned on my paper, and also that with that help of that mathematical expressions I have done that calculation in MATLAB. So that's I only here paste the results over here.
Actually, ma'am, it is the implementation of your flow diagram.
Yes, sir.
तो उसको दिखाई दोनों को दिखाइए ना.
Yes, this one, sir.
अब इसका implementation बताइए. उसमें शुरू करना.
This implementation in my
Yes,
pseudo
yes,
code.
yes, yes.
So it is only the closed loop architecture which I proposed you. This is only the closed loop architecture which I am proposing in my research paper. And through these, this is only the algorithm part. These are only the steps which I am going to do. And in my paper, I mentioned the mathematical expressions, formulas, how this results has been come. Thank you.
Thank you, ma'am. Now I would like to invite Ms. Anushri Gupta. Her paper is titled Design and Development of Deep Auto-Encoder Models for Detecting Abnormal Patterns in Industrial Process Data.
Good afternoon, everyone. Thank you so much, ma'am, for giving me this opportunity to present my paper. And my title of the paper is Design and Development of Deep Auto-Encoder Models for Detecting the Abnormal Patterns in Industrial Process Data. These are the outlines. abstract, introduction, literature review, research gap, objectives, methodology, results and discussions, conclusion, future work and references. So in the abstract, basically the paper is dealing with the drawbacks of detecting the manual of huge amount of data from the sensor data is difficult as the data is very high dimensional. The data is non-linear as well as it contains the noisy environments. The fault labels are often not available in the data sets. And so the use of auto-deep encoder is done, which is learning about the normal industrial behavior from the model itself automatically. And it does not require any labeled fault data for the purpose of further processing. That it is detecting the anomalies using the reconstruction error, which is the difference of the original input and the reconstructed output. It handles the noisy data environments by removing the noisy or unlabeled data or the data which is not required. It works on the multivariate time series data, that is data collected over different instants of time. These are the results which are expected. Like accuracy is of 96.8%, precision of 95.4%, recall value of 97.6%, F1 score of 96.5%, and false alarm rate is 3.5%. 3.1 to 3.5%, it varies. Now, in the introduction, the problems addressed in the earlier method is that if in the modern industrial data, if any small fault comes, it may lead to the production loss and even the safety hazards. The challenge which is basically faced is of how can the abnormal features in the machine can be detected before the machine is caused as a complete damage. The traditional methods are failing because it is dealing only with the data relationships. It is using only the Gaussian distributions, and the individual should have the complete knowledge of the entire system, which is basically a great challenge. And so the data which is gathered from industries is non-linear. It may have high dimensionalities. It can be dynamic and has the noisy environments. And the solution in which I am dealing in this paper is of deep learning approach, which is learning hidden patterns automatically from the data. Then it is also handling the high dimensional data. This is the literature review. It is having the methods of autoencoders, the data set which are being used, the accuracy or the advantages, and limitations as well as the drawbacks. First is this AMI's recurrent autoencoder, which is having the data set of TEP, as I have also used the TEP data set in the paper. The accuracy is in learning temporal relationships and somehow dealing with the spatial relationships also. Accuracy is about 95% approx. The drawback or limitation is the high computational complexity for the real-time deployment. And these are the 5 to 6 are there, and they are all from 2025 references. The research gaps. The existing limitations which have been noticed is due to the high computational cost, the poor adaptation to the noisy industrial environments, and limited exploitation of both the spatial and temporal information. The temporal information is dealing related to the time series data as well. Then difficulty in handling the fault conditions. It also reduces the efficiency as well. Then reduce the iterability and scalability of the data. The identified gaps are learning the spatial and temporal dependencies simultaneously is the best solution. Then detecting the abnormalities using the unlabeled industrial data and maintaining high accuracy over the different operating conditions. The problem statement is developing the unsupervised model that is capable of learning automatically from the normal data without having the need for the unlabeled data, and also detecting the abnormal behaviors from normal data while handling the non-linear high dimensional and multivariant time series data. The objectives is to develop a CNN LSTM hybrid deep autoencoder model. The CNN is used for capturing the spatial features, whereas the LSTM is capturing the temporal data, which is depending on the various instants of time. Then detecting the abnormal patterns using the reconstruction error. Again, the error which is caused by taking the difference from the original input and the reconstructed output. And evaluate the robustness under the noisy and varying industrial conditions. This is the proposed methodology of CNN LSTM hybrid deep autoencoder. The CNN, as I already mentioned, it is used for capturing the spatial relationships, whereas the LSTM, it is the long short-term memory. It is capturing the temporal dependencies and also remembering the previous data. The data set I used is of TEP. The data set split is of training, validation, as well as the testing phase. The training is 70%. Validation and testing both of 15% each. The process, the methodology contains of different processes. First is the data pre-processing, that is handling of missing values, normalizing the values, and then cleaning the features, like removing all the unwanted features. The architecture consists of encoder, which is having both CNN as well as the LSTM layers. Then latent space, basically the autoencoder contains three main architecture. That is, first is encoder. That main purpose of encoder is to just compress the data, remove all the unwanted features, and then represent it in the latent space. And the work of decoder is to reconstruct the original data again. Mathematical formulation. Input data, the input which we are giving, it is basically the time series data. Then convolutional and LSTM encoding. Here the encoding part is done and the reconstruction is done. The reconstruction also gives the reconstruction error also. The model training. The normal process data is passed. The loss function is calculated using the reconstruction. Then optimization is done and finally the overfitting is calculated. This is the flowchart. The input data is the multivariant time series data.
Ma'am, just a gentle reminder that 8 minutes have been passed. You have 2 more minutes.
The convolutional layer, it is the part of the encoder which is having spatial extraction of features as well as the LSTM layers for temporal pattern learning. Then the latent representation is done. Then multivariate LSTM and convolutional layers, and it is the part of the decoder. Then reconstruction error is calculated, taking the difference of the original input as well as the reconstructed output. Then from the reconstruction and threshold values, if the error is calculated which is less than the threshold, it is considered under the normal condition. Whereas if the error is greater than the threshold value, it is detected as an anomaly. And in the robustness analysis, the anomalies which are detected is of 3 times. If it is between 1 to 5%, it is the minor fault. If it is between 10 to 20%, it is the major fault. And if it exceeds the 20%, it is the noisy conditions. These are the data sets. Total 52 process features are there, and these are some of the features. These are the results. In the first graph, the blue part is of a normal condition, which is having the low reconstruction error. In the orange part, it is the abnormal conditions where the reconstruction error is comparatively high. Then second is the ROC analysis, which is comparing the true false rate as well as the false positive rate. These are the metrics value. Accuracy is 96.8%, precision is 95.4%, recall is 97.6%, F1 score is 96.5%, and false
Ma'am,
alarm.
your time is over now. You have 5 minutes per question and answer round.
Clear topic. Right. Have you compared this to previous work?
This is the first one.
The previous work means that the base which you have taken.
Yes, ma'am.
Have you compared?
Yes, ma'am.
So can you please tell me the comparison between the previous one and yours?
The previous one, these are the drawbacks. These are the drawbacks, and the previous one which I studied, the high dimensionality is the issue coming, and the data is not giving the accuracy in the noisy environments.
How many parameters they have chosen?
I worked on accuracy, precision, and recall.
How many parameters they have taken?
They have dealt with many parameters, but I have studied about the accuracy, precision, and recall.
You have taken how many parameters?
I have taken all these result and all these parameters.
These are the parameters: accuracy, precision, recall, and scores.
FN score and false alarm rate.
So, how many total parameters is this?
These are total 5.
And they are the previous paper?
Previous they have many, but I have done only study on 3.
So, which portion you have compared?
Accuracy, precision, and recall.
So, what's the accuracy about that, the previous paper?
Accuracy is about less than 80%. The precision is about 90%. And recall I don't remember.
They have chosen the same as the CNN.
They have a separate. CNN is different and LSTM on different one. This I composes a hybrid one that is having both LSTM also and CNN also.
Do you mention this paper, base paper in this
References is one.
literature review? Which paper?
First
Which paper
one.
is the base one? Base paper?
First one. And data set it is TEP data set.
Which year it is published?
2025.
25.
References I have mentioned.
So the accuracy is 95%. And on your result, what is the accuracy?
It's the same.
96.
Same accuracy. You said less than 80% at that time. That's it.
And these are the references.
कि मैम वो तो
And ma'am, these are the 7
80% बोल
references.
रही है तो जो है तो 195.
ठीक.
ओके.
Next.
सेम वर्क को कंपेयर करना रहता है ना, माइनर मॉडिफिकेशन होना चाहिए, वो सारे डिफरेंट एल्गोरिथम.
Next, I would like to invite Mr. Rohit Gedam. His paper is titled GA Optimized RLS Based Shunt Active. Next, I would like to invite Abhimanyu sir.
Good afternoon, Session Chairman, Dr. Nikhat ma'am, and good afternoon to everyone. I am Dr. Abhimanyu Singh from Madhya University. I am presenting my paper titled GA Optimized RLS based Sun Active Power Filter Power Quality Improvement under Non-Linear Loads. These are outlines: abstract, introduction, literature review, research gap, objectives, methodology, resultant discussion, conclusion, and future works. The proposed system used a genetic algorithm optimized recursive least square technique in a sun active power filter to improve power quality in 3-phase distribution system. Actually, my work is on RLS, recursive least square technique, which is along with genetic algorithm. I have designed a controller for remove the TSD, total harmonic distortion. The RLS algorithm accurately extracts fundamental and harmonic current components, while GA optimally tunes RLS parameter for faster convergence, lower estimation error, and better timing performance. The model was implemented in MATLAB, built and tested under nonlinear load conditions. using a waveform analysis, FFT, spectra, and TSD evaluations. Results showed significant harmonic mitigation, reducing voltage TSD to 1.55% and current TSD to 6.49%, outperforming the conventional PQ theory based SFPF and enhancing overall system reliability. Introduction. Increasing use of nonlinear routes in power electronic devices causes power quality problems such as harmonics, reactive power demand, voltage distortion, and reduced system efficiency. Shunt active power filters improve power quality by injecting compensating current equal and opposite currents, thereby reducing harmonic correction power factor and maintaining sinusoidal source currents. The RLS algorithm provides fast and accurate estimation of fundamental and harmonic current components, but its performance depends on proper parameter tuning. The proposed RLS SFEF combines genetic algorithm optimization with RLS parameter tuning, resulting in faster convergence, lower estimation error, and superior harmonic compensation under nonlinear load conditions. My proposed controller is there GA-RLS SFES, genetic algorithm, recursive least squared, subjective power filter controller. This is my model, simulation model, active power filter design in manual assembling driving non-linear loads. In this model, first of all, three-phase source, after that LC filters, and for measuring the voltage VABC, and here is the LC filter also. After this, bus bar is connecting for loads and the source. At the end of power filter is there, which is connected with GA and RLS. These are literature review from previous writers. I have taken some writers. Some TSD is under IEEE standard 519 and some is more than that standards. Here first writer, shunt active power filter is used, and his optimization technique is GA optimized PR controller. But for advanced region, I have used RES. Research gaps. Most existing SFEF studies focus on controller optimizations, but accurate and adaptive harmonic estimation under dynamic non-linear loads remains a challenge. Techniques such as PI, PR, PSO, and fuzzy logic and hybrid optimization improve performance, but often suffer from slow convergence or estimation inaccuracy. Very few studies have investigated the application of genetic algorithm with recursive least square for optimal harmonic distribution in three-phase SFEF systems. There is a need of GA-RLS based SFEF that provides faster convergence, lower estimation error, better dynamic response, and enhanced TSD detection under varying operation conditions. These are the objectives. First of all, to design and implement a genetic algorithm optimized recursive least square based selective power filter for harmonic and reactive power compensation in three-phase nonlinear load conditions using MATLAB. To adaptively extract fundamental and harmonics current components using recursive least square and enhance dynamic tracking performance through genetic algorithm. Based parameter optimization. To evaluate the effectiveness of the proposed GA-RLS SFEF in reducing voltage and current total harmonic distortion at the end point of common coupling and compare its performance with conventional PQ theory-based SFEF. To validate improvement in power quality, indicators including TSD detection and source current sinusoidal behavior under nonlinear load condition using FFT and time domain analysis. Methodology. The system measures three-phase voltage and current in the RLS algorithm to accurately separate fundamental and harmonic current components. Genetic algorithm optimize RLS parameter to achieve faster convergence, lower estimation errors, and improve dynamic performance. The optimized estimator generate reference compensating current, while a DC link controller and VSI ensure accurate current tracking. The SFEF injects compensating currents into the grid, reducing harmonic compensating reactive power, improve power factor, enhancing overall power quality. This is the methodology part. Figure 2 shows overall flow chart of the proposed GRLS based shunt active power filter. Simulation results validate the effectiveness of proposed GRLS based SFM in improving power quality and reducing harmonic distortion under non-linear load conditions. Figure 3 shows total harmonic distortion analysis of terminal voltage showing 16.5 TSD due to harmonic distortion caused by non-linear loads. And figure 4 shows TSD in current at the non-linear flow terminals with PQ control algorithm. Figure 5 shows TSD analysis of load current with the proposed GRLS SFER showing reduced current distortion and TSD value of 6.49%. That is number. Figure 5 TSD in current at the non-linear load terminal with proposed GRL SFER design.
क्या कंपेयर कर रहा है इस टाइम को
एक्चुअली मैम ओवरऑल क्या है पावर क्वालिटी इंप्रूवमेंट करना था जिसके लिए जो IEEE स्टैंडर्ड है 5% उसके नियर अबाउट लाना है तो मोस्टली काम जो हो रहा था जी पे हो रहा था जैसा भी आपने देखा लेकिन हमने आरएलएस पे उसको कंबाइन किया है एक कंट्रोलर डिजाइन किया है सन टेक्निक
कंपैरिजन है दोनों को अलग करने का
मेरा जो रिजल्ट आया है करंट जो TSD वोल्टेज का आया है वो 1.63% आया 63% आया जो कि वेरी लो है स्टैंडर्ड 5% की लिमिट है और सेकंड वन जो आया है 6.49% आया है जो प्रीवियस था उसमें से जो वोल्टेज में है माइनर चेंज हुआ है बट जो करंट TSD है वो ज्यादा चेंज हुआ है
थ्रेशोल्ड वैल्यू किस पर फिक्स
IEEE का स्टैंडर्ड 5% का है
थ्रेशोल्ड वैल्यू
IEEE स्टैंडर्ड 519 जो है वो
ये तो ज्यादा है ना
हाँ बट परफेक्ट पहुंचने में टाइम लगेगा अभी और आगे जो है अभी जो करंट किया है और बाकी चीजें
तो करंट TSD 6.49% तो
कंपैरेटिवली जो किया है मुझसे बेहतर रिजल्ट्स है
तो रिएक्टिव पावर कंट्रोल की ट्रेडिशनल टेक्निक्स कौन सी कंपनी
आजकल जो ये जेनेटिक जैसे मैम ने भी बताया था जो एआई और जो इतने एआई वाले हैं ये कम से कम 1960 से चल रहे हैं सारे आजकल जो कंट्रोल एल्गोरिथम आए हैं वो एक्चुअली रिजल्ट एप्रोप्रिएट नहीं दे रहे हैं तो आज भी जो इलेक्ट्रिकल में है ये पुराने ही चल रहे हैं और अच्छे रिजल्ट्स दे रहे हैं इनको हम कंबाइन करके इंटीग्रेट करके कर सकते हैं
फिजिकल इम्प्लीमेंटेशन में ये तो आपने
फिजिकल
क्या
मैटलैब में किया है
क्या
इम्प्लीमेंटेशन एक्चुअली इलेक्ट्रिकल में आज भी एक चैलेंज है उसको करना थोड़ा सा मुश्किल भी है
ये तो फिर ये ऑन पेपर रिसर्च है क्या
ऑन पेपर रिसर्च सर इलेक्ट्रिकल में जनरली मैटलैब पे ही चल रहा है जो इलेक्ट्रिकल देख रहे हैं उसको
मैं पूछा हूँ इन रिजल्ट्स की फिजिकल वैलिडेशन कैसे कर रहे हैं
मैटलैब
सर वैलिडेट कैसे करते हैं
वैलिडेट कैसे करेंगे
वैलिडेशन कैसे किया हुआ
मैटलैब के थ्रू सर
कैसे कैसे वैलिडेट
प्रीवियसली
MATLAB is in software
हां सॉफ्टवेयर से निकाला प्रीवियसली
वैलिडेशन कैसे होगा
आपने जो आपके रिजल्ट्स आए हैं उसको किससे वैलिडेट किया होगा कोई टेक्निक होगी ना पर्टिकुलर
नहीं अभी जो हमने जो यूज किया है GRLS टेक्निक यूज
यू
किया
ऑब्टेन रिजल्ट फ्रॉम द मैटलैब
यस
आपने बोला कि भैया TSD 1.63 और 1.55% ही आपने जो भी डिफरेंस बताया इसको आपने कैसे बोला कि ये सही है
ये इसको वैलिडेट कैसे कर रहे हो
जो स्टैंडर्ड लिमिट है उसको नियर अबाउट अपने को लाना है सर उसको जो स्टैंडर्ड लिमिट है उसके नियर अबाउट लाना है तो उसमें तो और सुधार से इसमें और चेंजेस हो सकते हैं
Sir, just a gentle reminder that 11 minutes have been completed.
I think we should clap for the participants.
Now I would like to invite Ms. Ritu Srivastav. Her paper is titled Graph Weighted Extreme Learning Machine based on multi-view learning.
Good afternoon, respected chairpersons and everyone. I am Ritu Srivastav, PhD scholar from Center for Artificial Intelligence, MIT Square. Today I am here to present my presentation on graph-based extreme learning machine based on multi-view learning. Here is my outline of today's presentation. So when we go with the real-world data set, it has two types of problems. One is a severe class imbalance problem. When we see the data, it is not a balanced data set. For example, fraud detection and type case data set, it has one class has a majority samples and other class has a minority samples. So we have one machine learning model, extreme learning machine. It is very fast and it work with the neural network technique, but it is not just like a traditional model. And when we go with the imbalanced data set and multi-view data set, it is not good. Therefore, we propose GWLM-MV. And we integrate three techniques: graph embedding, multi-view, and class imbalance. So to handle the class imbalance, here we use class weighting, and to handle the geometric structure, here we use graph embedding, and third one is that multi-view. Many of the traditional models use single view. Here we are taking the data set in the two view. When we tested our model on the real world data set which are coming from the Kiel or UCI repositories, we have a very good result when we compare to the baseline models. Before going forward, let us understand about the basic terminology that I applied in my model. ELM, as we know, extreme learning machine is very fast and it is a closed form solution, but it is a non-iterative trading. It is not just like as a traditional model where we use the back propagation algorithm. But it has a problem. It treats all samples equally. So it is good with the class imbalance, but it is not good with the imbalance. Second one is a WLM. WLM is weighted extreme learning machine. It is good with it is an extended version of ELM, but it is good to handle the class imbalance problem, but still it has a problem just like as it doesn't cover the geometric structure of the data and also a graph embedding technique. Graph embedding is the supervised dimensionality reduction technique. Here we are using the local feature discriminant analysis. It is a very good method that uses the two-dimensionality reduction method, and the goal is to its goal is to within a class similarity, because when we have a two type of samples, so we want that inside the circle we have the points which are close to each other, and when we have a two circles which have a points but that two circles are different to each other, it is called the between class separation. Why we are focusing on the multi-view learning? Multi-view learning, as we know that traditional machine learning models use the single view. For example, here is the graph. We can say that we can say hello in many of the languages, just like as in English, Chinese, or French language. So most of the information we can capture by the help of multi-view dataset. We already know about the class imbalance. Here is my literature review. In first paper, G.B. Huang, they introduced the ELM. In 2006, they proposed ELM. So it is not just like as a neural network. So here we can see that how ELM works and how Murray-Penrose inverse method work in the ELM. After that, WLM is come here to reduce the class imbalance and then boosting ELM. All these techniques work with the imbalance, but it doesn't combine all these three techniques together. Also, for the multi-view learning, we have a review paper, and all these paper regarding the last one is the GRBFL MB paper, which is our baseline model that I have compared our model with the GRBFL MB. It is proposed in 2025 recent paper. Here is my research gap. After the literature review, I have found that graph ELM is there, but it doesn't handle the class imbalance problem, and WLM handles it, but it doesn't handle the geometric structure multi-view problem. GRBFL MB is very good, but it is still have a problem with the class imbalance dataset when we tested on it. So there are some gap. So there is no existing work with the three of these techniques. So our objective is to make the single model that combine all these things and resolve class imbalance problem, multi-view problem, and geometric structure problem. So our target is to consider all these things and make the model that can handle all things. Here is my methodology. I simply explain this methodology flow diagram. First of all, we will start with the class imbalance data set. After that, when we have a class imbalance data set, when we go with the data set, it has some feature that is not normalized, and most of the data set has no trend test splitting. So in data processing techniques, we can split the data, also use the sample weighting. Here, multi-view, by the help of multi-view, when we have a balanced data set, we divide the data set in the two view. After that, we apply the graph embedding technique, which is LFDA, that compute the SW and SP. Compute within class scatter and between the separation of two classes. After that, WLM works to classify how much model give the good result, and then evaluation matrix. Here is my objective function where C1 and C2 is our regularization parameter, and A and B are the two views of the model. Beta A and beta B here is our model one view, model A view,
Ma'am,
and
just a
model
gentle
B.
reminder that 8 minutes have been passed. You have 2 more minutes.
Here is my result when I compare with the data set. Here is my benchmark data set and accuracy. When we go with the accuracy, accuracy is good for the balanced data set, but it is not good for the imbalanced data set. Therefore, we cannot rely on the accuracy. So, we will compare our data set with the AUC and GB. Here is my ROC curve of the model. We can see that our model, according to area under curve, we have a good performer, most of the data set. And when we have a result, then we validate our result by the help of statistical techniques. Wilcoxon is a non-parameterized test, and we can say that AUC and G-mean has a significance difference. So, to conclude that, we make the GWLM MB that solve all these three problems: class imbalance, geometric structure, and multi-view problems. And my future work, because I already here shown that I have used the binary data set, but I want to use this model on the multi-class also. Thank you. Keel and UCI repositories. Keel repository and UCI repositories. It has an imbalanced data set. they already applied on their on their website. So when I go through the literature review, the most of the papers are used that data set from the Keel and UCI repository. So from where I have gone through the Keel and UCI repository. There is a many type of data set, balance as well as imbalance. It has also a noisy data set also.
So how many parameters you use for comparison parameters?
Comparison, we have a evaluation matrix AUC, Z-mean and ROC curve, because when we go with the AUC um, in a numbers manner, so we cannot rely on that. When we go with the ROC curve, then we can see that how much on which data set, because when we see that here is a different data set and it has a different imbalance ratio. Some has a more imbalance ratio. For example, Equality 3 has 8.60 and Avalon 918 is a highly imbalanced data set. Therefore, we have to prove by the help of ROC, area under curve, and by the help of G-mean. G-mean is very good for class imbalance technique.
So here you get an ELM, RPLM and WELM. Can you please tell me about that?
Okay.
Because you have mentioned the
Yeah.
compared with these.
Yeah, our proposed model GWLM MB, and we compare that model with the
ELMB.
GWLM, graph weighted extreme learning machine based on multi-view. And we compared with our model by baseline ELM and RBFL. It is also a randomized neural network just like as ELM, and WELM, weighted extreme learning machine, and GRBFL MB, which is a recently proposed graph random vector functional link based on multi-view. Actually, it is my baseline paper. By the help of this GRBFL MB paper, I have an idea about that, why we are not applied this GWLM MB, replace that GRBFL and tested on that, and we find that it has a good result.
Where we have implemented this?
By the help of Python.
Where we have implemented this, and what is the use of your research?
Use of that research, because many real world data set, for example fraud detection, diabetes data set, when we go that type of data set, so a lot of if we will go with the fraud detection, a lot of examples we can see that it is a non-fraud customers, but there are very few customers which have a fraud. But when we go with that machine learning technique, traditional technique, it can capture majority data set, but it will means वो छोड़ देते हैं minority class को. तो हमने जो ये मॉडल बनाया वो माइनॉरिटी को भी कैप्चर कर रहा है, मेजॉरिटी को, तो वो अपनी जो नॉलेज है उसमें मिस नहीं कर रहा है. वो छोटा भी डेटा सेट बहुत इम्पोर्टेंट है हमारे लिए.
ठीक है मैम, की एरिया वही हुआ ना आपका.
Thank you so much. Now I would like to invite Ms. Prachi Parashar. Her paper is titled Multi-Scale Feature Learning Network for Underwater Image Restoration on Edge Devices.
So, very good evening to all of you present here. I, Prachi Parashar, PhD scholar, IIT RGPB Bhopal, and I am going to present, and my topic is multi-scale feature learning network for underwater image restoration and edge devices. So first of all, I would like to introduce about the particular topic, why this topic particularly I choose, because lots of cameras and lots of image quality enhancement devices we are currently using. But yeah, definitely, as we see underwater images, there are still some problem, because whenever we capture the images into the underwater, we see that there will be the different characteristic into the underwater. There will be the distance and size of the images are different. So I choose that particular topic to study and research on these particular things. So I covered these outlines basically. So now come with the abstract. So basically, what is the problem introduced for the underwater images? So there will be the numerous problems occurred into the underwater images. Some I mention here, that noise interferences. Noise interferences means there will be the reflection, scattering occurs into the images, and there will be the texture blur, because whenever images will be or objects routine into the water, there will be different texture blurriness and scattering process occurred. So there will be some proposed method which is already working over in this particular research way. These are the lightweight unit based CNN architecture, fusion of shallow texture features and deep semantic features. So I included that lightweight unit based CNN architecture. This basically covers the shallow, means this will be the low data consumption and high accuracy will be given into these particular technology, or we can say this particular algorithm, and this will reduce the parameter faster network convergence, multi-scale pyramid pooling for enhancement detail restoration. That multi-scale pyramid pooling means basically there will be different algorithms already available into the studies, but they have complex computational and we can say less accuracy, or they can make a bridge between the accuracy and complex computational. So basically this multi-scale pyramid pooling having the less number of computational things, because it will work on the frame by frame. That means whenever we talk about the underwater images, it basically having the different texture and different size. As I discussed that into the water there will be different sizes occurs because of the scattering and absorption of the object. So that multi-scale pyramid pooling having not one scale studies, that will be the multi-scale multi-dimensional scaling is occurred into the pyramid pooling, and joint optimization using L1 loss and SSIMS loss. This combined effect will be give the low structure, yeah, or we can say level 1 loss, and SSIM similarity index will give the combined effect to enhance the quality of the images. Edge deployment gives edge deployments, basically we talk about the whatever hazing problems occurred into the water images, that like satellite images and marine drive images that occurred with the edges of the, or we can say boundaries of the images, that suffers from the lots of problem, that give the edge deployment for this. Now move towards the introduction of the multi-level, multi-learning features of the images. So here that underwater images are crucial for exploring and developing the underwater world, with applications in underwater archaeology, marine ecological research and target detection. However, image quality issues hinder the accuracy of practical applications. Researchers have developed underwater image sharpening algorithms, but a robust evaluation system is lacking. As I said that there will be multiple techniques and multiple algorithms already there into the research, but yeah, definitely there will be some research gap is already occurred, which can be covered up with the different view of the studies and research. So object evaluation uses computer simulation categorized as full reference, partial reference and no reference. Basically, whenever we talk about the image enhancement and restoration technique, we can say there will be the multiple reference images are there whenever we take the pictures into the real life. But whenever we talk about the underwater images, so we work on the no reference images because we don't have reference image for the underwater images existing because of no reference images. So that's why I take the example of the not reference methods for neural color images are not suitable for underwater image due to water effects and the absence of clear references. These are the literature review. There will be numerous papers are there to studies and to cope up with the research gap. There are different multiple techniques already there like CNN, machine learning. Nowadays, deep machine learning and deep machine learning techniques are already infused with the underwater images. But I choose that CCS, that is cross convolution spatial algorithm to enhance the underwater images quality and as restoration technique. These are the research gap. There will be machine learning based no reference methods widely used, contrast and neural images, metrics such as QI/QM, UI/SM, and I said that I work on the cross convolution spatial algorithm. So these are the research gap. Now I want to come on that particular CCS method. This is the basically cross convolution spatial, which on particular which I work over there. So these are the basic block diagram. There will be introduction of the cross convolution spatial method addressing underwater challenges. Whatever there will be underwater images, challenges occurred on the algorithm. Human perception alignment and empirical
Just a
validation.
gentle reminder that 8 minutes have been.
Sure. So, introduction of CCS method, proposing a novel and unreferenced underwater image quality evaluation method, addressing underwater challenges, identify and addressing issues such as I said, blur, low contrast, color imbalance, unique to underwater images, texture blurriness, boundary hazing techniques over there. Then human perception alignment. So in the studies, there will basically two alignments occurred over there. One is the atmospheric alignment and human perception alignment over there. So in the human perception, we cannot computational things over there, but yeah, definitely into the atmospheric algorithm or into the atmospheric thing, we can do the both accuracy as well as the computational algorithm. So next will be the empirical validation, demonstrating the effectiveness of the CCS algorithm through experiment that shows its accuracy in evaluating underwater image quality compared to other non-reference algorithms. This is the block structure of the methodology where different blocks cover the images and proposed methodology will be worked on that. That I already said that lightweight unit, because this unit will be structured in the unit and multi-layered framework, and lightweight will be abbreviate for the whatever works or going on, that will be the very much complex computational over there, but it will be work on the specific data set, limited whenever we work on the limited data, there will be accuracy will be high. These are the results and things over there. Different method that RMSE.
And your time is over.
But just fraction of seconds I'm covering over there. These are the basically graph which is shown in the result. There will be comparison between the basic technologies which is already over there, and I work on the CCS. Some parameters are less, but yeah, more ever, lots of parameters will be enhanced. These are the conclusion and future work. CNN methods will give the correlation and mean square values into the appropriate level. But yeah, there will be future scope is there, that complex underwater images, and I can want to extend that work on the videography. Basically, this will be the specific on the frames like images. But yeah, definitely we take video into the underwater. That can be future scope for this particular type.
It's like you are going for the underwater images, because underwater images is very large. So which part you are going to cover?
Ma'am, basically there will be no any segregation between the underwater images. We can say that marine drive, archaeology, these all are the covered with the underwater images. We can say there will be the, whenever nowadays people doing scuba diving, there will be the underwater, means real life images are also captured, and there will be into the marine drive, archaeology, there will be lots of images into the underwater.
Because so you are taking as a large.
Yes, ma'am, there will be data set already available into the different platform.
So
it is open access.
Image detection techniques, what you have chosen?
Basically, ma'am, data set I have chosen from the Kaggle. There will be into the lakhs open access data sets are available. And technique I have chosen that CNN is the basic technique. But in this, because of lightweight unit category, I choose that CCS method.
Have you gone through the comparison of the same?
Yeah. Any other questions? Thank you very much to watch.
Now I would like to invite Ms. Yashika Nigam. Her paper is titled AI-driven dynamic customer behavior intelligence framework using deep learning.
Good afternoon. Hello. 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 Good afternoon, everyone. This is Yashika Nigam, an MTech scholar from IEEE. My topic for today is AI-driven dynamic customer behavioral intelligence framework using deep learning. And my co-authors are Dr. Nishal Mishra and Yogendra P.S. Nayak. This is my basic outline. This is my basic outline for today's presentation. Now coming to the problem. What is the problem which we all are facing with today's data? So every day, huge amount of data has been generated, but it is of no use until and unless some model has been used to form an intelligence framework. So digital retail platforms generate large-scale customer transaction data, but generally previous studies have not shown
an intelligence framework. Traditionally, RFM-based customer intelligence framework has been mostly used in the previous studies, which is static and not very dynamic in nature. These RFM techniques do not generally capture non-linear customer behavior features. That's why we will be moving to dynamic proposed framework. So my topic is AI-driven dynamic customer behavioral intelligence framework, in which feature engineering has been used. We have created 11 basic features from the given features, and those features has been input into autoencoder and k-means for the customer segmentation. Later, for the transition analysis, Markov algorithm has been used, and for the next segment prediction, XGBoost has been used, and for the deployment, a web-based application Streamlit has been used. So these are the key. Also, I've shown the key results, which I'll be showing later as well. So autoencoder and k-means have shown the select score of 57%, while the XGBoost have achieved the accuracy of 78%. So why customer intelligence is important? Because we already know that a huge amount of data is being generated on a daily basis, and it is very important for many companies to use that data to generate a higher revenue. So we also know that customer behavior changes over time. To analyze those customer behavior, we need to understand how data has been working. And the static segmentation only gives customer groups, not the prediction of the future segment. So dynamic prediction helps the retention and personalized marketing. This is the literature review. Many studies have seen that Zhao and Liu have focused on only k-means, and it is generally static, while Liao worked on neural network, but it does not show any movement of the customer behavior. Lin, on the other hand, has used temporal behavior, which is not very practical enough. Meena has used RFM with deep neural network, but again, it does not show the future segment, how future segment is coming, or it is just focused on the churn of the customers, churn behavior of the customers. So my proposed framework is mostly about, it contains 4 major algorithms, which are autoencoder, k-means, Markov, and XGBoost. So autoencoder plus k-means help to understand which segment the present customer is there, and with the help of Markov, we can understand how customer movement has been happening in the past and even in the future. And XGBoost helps to predict the future segment, future 1 month segment of the customers. And with the help of Streamlit, I have deployed the model. Research gap. With the help of previous studies, I have found out 4 major research gaps, which are basically static segmentation. Mostly studies have used static segmentation only, and there is no next segment prediction of the customers. They have only analyzed which segment currently the customers are in, and there is only limited transition analysis. Like I have used Markov for the transition analysis. So there are only limited studies which have used transition analysis for now, and only a few studies have deployed that model for the better decision making. So the first objective of my study is pre-process the detailed data. So for pre-process scholar, na? Yes. You are MTech scholar. Yes. So how many objectives you have taken? These are the objectives, ma'am. All the objectives. All the objectives you have taken. Yes, ma'am. PhD scholar. MTech scholar. Yes, ma'am. So first I pre-process the transitional data. So we have seen that data is not very practical to use. Whichever data we take, it is not practical to use. There are many customer IDs which were missing in this data. Many transactional errors were there in the data, which I have eliminated throughout the process using different processes. Next is feature customer. I have created advanced features. Basically, I have created 11 advanced features which were later taken input in the algorithm later on. Then those algorithms are, I've already told, autoencoder plus k-means for the customer segmentation, then XGBoost for the next segment prediction, and Streamlit for the deployment of the model. This is my proposed methodology. Firstly, I've taken UCI retail data from the Kaggle. This data has been pre-processed and with the help of feature engineering, many 11 features have been created. Now this methodology divides into two parts. First is static part, second is dynamic part. In the static analysis, feature scaling has been done. Then those features has been put into autoencoder for the latent representation learning. Later, once the autoencoder learns how the features are behaving non-linearly, the k-means helps to understand the segmentation, the current segmentation. In the dynamic path, monthly snapshots has been taken, and those snapshots, with the help of those snapshots, Markov transition analysis has been done, and later next segment prediction with the help of XGBoost has been done. These two parts has been combined and later taken up for the decision support in the deployment section. So this is my experimental setup. Data set has been UCI retail data set, and the pre-processing I have removed the customer IDs, removed the cancelled transactions, removed the invalid quantity unit prices, created customer level features and snapshots. The features are the 11 features I have been telling you about. Those are recency, frequency, monitoring, total quantity, unique products, customer lifetime.
Ma'am, just a gentle reminder that 8 minutes have been passed.
Thank you. So these are the 11 features, and the models are autoencoder, Markov, and XGBoost. These are the final results. So first, we can see the segmentation results. If I use RFM with k-means, I've got 37% as a score. Then I use GMM, the score improved to 40%, but it was still not very good. Then with the help of autoencoder and k-means, 57% of the silhouette score has been achieved. Now the prediction of the segmentation result, obviously we can see that tuned XGBoost has worked the best.
You are going for market behavior or customer behavior? You are going for market behavior, customer behavior.
I am studying the customer behavior, and with the help of studying the customer behavior, I have proposed a model through which we can analyze the strategies which we can apply to retain them.
Here the topic is actually dynamic customer behavior intelligent framework.
Yes, ma'am.
But your PPT shown as completely a market behavior, not a customer behavior.
I have studied all the customer behavior, how customer is behaving. Later on, in the results, I'll be showing how the customers, in the next slide only.
Come to the next slide.
So this is the next slide. This is how the customers has been segmented. This is the graph of the. So they are
Categorize the VIP customers and potential customers.
Yeah, the data has been segmented into 4 segments. The first is VIP customers. VIP customers are high purchasing customers. Loyal customers are the frequent customers. While potential customers, they have been buying moderately but not much. And the journalists, which have already gone. So, with the understanding of these characteristics, with the segmentation, I have understood the characteristics, and with this, I can recommend the strategy, which strategy can be used to retain them.
So, how much the business is impact using for this?
How much?
Business impact using for this?
Business impact. Directly it can add to the revenue of the company. If we retain the customers, obviously getting new customers is expensive rather than retaining customers is more beneficial for the company in terms of revenue rather than getting the new customers. And this is the deployment gist of the my. I can also show you if the time allows. I can also show it later on. So this is the present and future work, and obviously the select score I have achieved 57%, prediction accuracy 78%. It is an end-to-end pipeline integrating segmentation, transition analysis, prediction, and deployment for customer intelligence. Future work can include real-time data. I can also include explainable AI, which can have sharp and line. Also, transformer and LSTM-based techniques can be used. Thank you. These are the key references. Any questions? If the time allows, I can show the deployment web page.
No.
Time is over.
Okay. Thank you.
वो लगा देना अच्छी वाला
So with this, we conclude the paper presentations. Now I request our guests and honorable dignitaries to kindly come forward for the certificate distribution.
सर पेन ड्राइव ले लो मैम को
IEEE वाला लगा दीजिए सर फॉर सेकंड बार जो कॉमन है बात आजी शकुंतला
May I start? So, to begin with, I request Ms. Richa Singh to kindly come forward and receive the certificate. Please give a huge round of applause. Thank you, ma'am. Now I request Ms. Anushri Gupta to kindly come forward and receive the certificate. Thank you, ma'am. Now I request Mr. Now I request Dr. Abhimanyu sir to kindly come forward and receive the certificate. Thank you, ma'am. Next time I request Ms. Ritu Srivastav to kindly come forward and receive the certificate. Thank you, ma'am. Now I request Ms. Yashika Nigam to kindly come forward and receive the certificate. Congratulations to all the presenters for their valuable research contributions. Now, I request all the dignitaries and guests to kindly remain on stage. I request our respected Dr. Sheetal Gupta ma'am, Deputy HOD, Computer Science Department, to present memento and certificate to Dr. Nikhat Raza Khan ma'am as a token of gratitude and respect. Please give a huge round of applause. As we come to the end of this technical session, I request all the participants to please come forward for a group photo.
आ जाइए पार्टिसिपेंट सब आ जाइए सर्टिफिकेट्स with your science certificates